Okay, I have two last parts that I'm going to cover for the next, let's say, 10 minutes. So it's not going to be a really long session. So we are going to talk for the next 10 minutes about the last two parts that I think that are going to be fun to see, and how these are going to make a specific kind of implication. Actually, there are three parts, but I will try to kind of compress them and discuss about the major messages that we have in these parts. Okay, one interesting experiment I want to show you that would show some interesting kind of implications out of the activations, brain activations that we might get. Let's think that you are running an fMRI task, that you are giving people a stimuli that to some extent could be scrambled in a way that you cannot see a specific object or face inside, or you can see the face inside. Okay, if you see these activations, you see these stimuli inside the scanner, you would have kind of activations in the brain. Obviously, in both, you would have activation in the visual cortex. This one would have a higher visual cortex activation. But as you can see here, there would be a specific activation regarding recognizing a specific object in the brain, in the probably fusiform face area, because we are seeing a face here and there is no face here. So we can see this contrast here by comparing these two stimuli together. But let's add another step to that fMRI task, and asking people to report whether they have seen a face or not. And in both conditions, they have the motor response. So in both conditions, the motor response would be there. So in both conditions, they still have motor condition. And as we are making the contrast between these two conditions, the motor response would be gone, because the motor response would be in both. So it would be subtracted and it would be eliminated from the activations. But when we are aware and we are reporting that, yes, I've seen that, compared to the time that you are just seeing them without even kind of recognizing that you are seeing them. So you are just being presented with these stimuli and you are seeing this stimuli without getting to a level of consciousness of, okay, I'm seeing them and I'm reporting I'm seeing them. Okay? And if they show you that contrast, you have a higher level of, let's say, frontal activation when you consciously reporting that I've seen that. People think that is an implication that the contribution of frontal cortex is important for conscious, reportable experience. So conscious, reportable experience would be reflected in the frontal area, as you can see here. And you have all other things as well in terms of, let's say, the fusiform face area, the contrast would be there. And we have a little bit of more activation in the visual cortex because of the feedback loops that we discussed about before, in terms of if we have something important in the visual field, your visual cortex would also get more activated, and mainly in the secondary visual areas. As I told you before, for the drug cue-related task, that most of the time we have higher level of secondary visual cortex activations because of importance of these areas in terms of kind of finding those elements that we are looking for in something like an active feedback loop, and paying more attention to the visual field because of finding a specific item there. So this is the kind of the activation map that you can find, and that is going to be, let's say, the contribution of the frontal side to this conscious reportable experience. I can probably give some other explanation for that, and that is the challenge in the field of fMRI. Sometimes you have an activation and you can bring, let's say, different explanation. Why do you have this activation? And sometimes there are people who are interested in the field of consciousness. They say that, okay, this is a representation of consciousness. But others in the field of cognitive neuroscience might say that, okay, I mean, this is not only consciousness, it's an interaction of, let's say, motor activations and conscious processing that is going to activate more frontal eye field areas. So there might be some other explanations for that as well. I'm not going to get to those explanations. The other important part of this process that I'm going to kind of discuss about that is about, let's say, the importance of frontal area. As I told you, this is the kind of the rat brain. If you give rat anesthetic, let's say, medication, and they put them in something like a sort of coma or anesthesia, just kind of give them something like a really deep sleep, you can see that the flow of information from the occipital areas to frontal areas would remain almost the same. So it seems that the visual system and the parietal system and the auditory system, they are still processing information to some extent, and they are kind of activating the frontal cortex. But it seems that the feedback information from the frontal side would just gone. And that is another reason that people say that the frontal part would contribute to the conscious experience, and frontal part would be more important in terms of engaging in the activations. It's quite interesting that at the end of the day, what you are recording from the cortex would be similar between the frontal and occipital and parietal, but the network level connection and the flow of information would be mainly from the back to front, not from front to back. It seems that the kind of the brain is in the same different parts of the brain, as I told you in the previous sections. When you are kind of slept, when you are asleep, the entire activation would be just gone in the cortex, but the flow of information is mainly, the remain flow of information is mainly from back to front, not from front to back. And that is the reason that the information would just kind of disintegrated, and then there is no, let's say, integrity of information that would make us conscious. And that integrity of information, together with all the kind of efforts that thalamocortical system is trying to organize or basically orchestrate, is going to be gone by, let's say, these anesthetic agents that would give you a deep sleep. And as I told you, this is the significant role of the thalamus cortex, to keep all these parts of the cortex organized in a way that is going to make us conscious. Okay, that was the part 5.